Hey guys, today we will be modeling lesson 32 problem set. You will be subtracting a fraction from a mixed number today. So you want to subtract using two different models, either a number line or the arrow strategy. So 3 3/4 take away 1/4. You want to first acknowledge that your unit fraction is fourths, so your number line will be definitely divided into 4 equal parts to model the number line strategy. So if we start with 3 and a little bit more than 3 wholes, which is 3/4, and we're still taking away a fourth, our number line will need to be 3 wholes up to 4 wholes. And if we want to divide this into 4 equal parts, we want to split it in half, and then we want to split each half in half. And let's go ahead and label that 3 1/4, 3 2/4, 3 3/4, and then we reach our 4. So our starting point is right here with our big number, which is 3 3/4. So we want to start there. And you want to always remember to know where your starting point is before you go backwards. We start at 3 3/4. We take away just 1/4, and you want to model that. Always remember to model what you're subtracting. 3 3/4, take away 1/4, lands us at 3 2/4 as our final answer. And then go ahead and hit pause, and you can do problem B using the number line strategy like we did for A. Now we will do C together and use the arrow strategy. We've got 5 1/3, take away 2/3. So we want to acknowledge that our unit fraction is going to be thirds when we reason this in our head. This is our starting point. Our large fraction here, 5 1/3, is our starting point. So you want to begin the same thing here. Your starting point here will be 5 1/3. And with the arrow strategy, you want to take away 2/3. But to do that, we want to decompose. Let's go ahead and decompose 2/3 the only way you can, which is 1/3 and 1/3. And if we decompose this, it makes it a whole lot easier because you've got a third here, and now you have a third here. So if I am subtracting on my arrow strategy, if I'm taking away 1/3 right here, I'm essentially just taking that part away, which is also subtracting that part. So 5 1/3, take away the 1/3, just leaves me at 5. And I continue my arrow strategy here, and I can't forget that I have this other third to take away as well. So if I take away the second 1/3, which I decomposed here, it takes me down to 4 2/3. Okay? So that brings me to 4 2/3. Go ahead and hit pause and continue on with problem D using the arrow strategy. Number 2 asks you to use decomposition. Model your decomposition to subtract your fractions, and again you can use a number line or an arrow strategy. So what we will do for this section is remember to show our decomposition over here on this side of the subtraction problem. 5 3/5, take away 4/5. And there is a reason why they chose to decompose 4/5 into 3 1. If you can see this 3/5 on this side, and you also see it here, that's why they chose, instead of 2/5 and 2/5, they chose 3/5 and 1/5 because of this comparison here. So let's go ahead and use our arrow strategy for this to show you how easy it is to, not a number line, we're going to use an arrow strategy first. So if this is our starting point, 5 3/5, and they want us to subtract 4/5, let's go ahead and subtract what we decomposed. Let's start subtracting with 3/5. And the reason we do that is because we can just take that piece off. If you just take off the 3/5 from here, that drops you right down to what you're left with, which is 5. And now all you have left to take away is 1/5 away from 5 wholes, and that leaves you with 4 and 4/5. All right, hit pause and do part B, decomposing 2/4 into the only way that you can, and show the arrow strategy for part B. Moving on to C, this time we will do the number line strategy for C. You've got 5 and 1/3 as your starting point, take away 2/3. So if we decompose 2/3 before we begin, the only way to do that is to decompose it down to 1/3 plus 1/3. And once we do this, we decide on our number line where our holes are going to be and how many we need. If I'm starting with 5 holes and a little bit more, and I'm subtracting 2/3, I'm going to want to begin my number line with 4. I need to go past 5 holes, so I'm going to need to go all the way to 6. And if my unit fraction is thirds, each of these holes needs to be divided into 3 equal parts. To get 3 equal parts, I make 2 cuts. 2 cuts here. That gives me 1, 2, 3 parts, 1, 2, 3 parts. So you want your holes to stand out. So now you need to label. 4 becomes 4 and 1/3, 4 and 2/3, and essentially this is really 4 and 3/3, otherwise known as 5. This becomes 5 and 1/3, 5 and 2/3, and then 6, otherwise known as 5 and 3/3. So what is my starting point? We said it was 5 and 1/3. This is where we start, 5 and 1/3, and now let's simply start subtracting based on your decomposition. I'm going to subtract my first third right there, and I'm going to model it. I need to subtract my second third, and I need to model that, and that lands me at 4 and 2/3. So using this decomposition as a model and this number line as a model, go ahead and do your part D, and just remember when you're decomposing 5/8, what did we say common sense told us for the 5/8? If I'm breaking down 5/8 into 2 pieces, would that be one of them that I wanted to use? Go ahead. Moving on to your last section, section 3. This looks a little bit complicated, but it's not. You want to decompose these totals, decompose your totals to then subtract your fractions. So if we look at this problem, the actual problem is really 3 and 1/8 minus 3/8. So that's your original problem. And your unit fraction is 8ths. That's what you want to be working in. But for this section of the problem set, boys and girls, you want to decompose the left side, or the side with the whole number on it. You want to decompose this every time. And what they want you to do is they want you to take 1 whole away from this side and bring it down here. 1 whole is essentially 8/8. If I'm taking a whole away from 3, it's 8/8, and since I took it away, what's left of this 3 and 1/8 is really 2 and 1/8. So once I have what's left here, then here comes the trick. You want to take this side of the problem, you want to take 8/8 minus 3/8. I'll say that again. You want to take 3/8 away from 8/8. And 8 minus 3 is 5, so you end up with 5/8. So you've essentially done your subtracting right here after your decomposition. So now you have 2 and 1/8, and you have to add the 5/8 from here, and that gives you your final answer of 2 and 6/8. Let's do part B to help you practice. 5 and 1/8, take away 7/8. Again, they want you to decompose this side of the fraction. First and foremost, take away a whole from this 5. If I take one whole away from that 5, because my unit fraction is eighths, I'm essentially taking away 8/8. And I'm left with, not 5 anymore, I'm left with 4 and 1/8. Okay? And now that I've done that, I simply want to put a ring around this, and I want to do my subtracting right here. 7/8. If I'm taking 7/8 away from 8/8, 8 minus 7 is 1, and I'm left with just 1/8. So now my problem becomes 4 and 1/8 plus this 1/8 that is left after I do my subtracting here, and my final answer is 4 and 2/8. Let's do one more before I turn you loose. 5 and 3/5 take away 4/5. Again, which side of the problem do we decompose? We decompose this side. Take one whole away from the 5 and put it right here. That is the same thing as saying 5/5. If I took a whole away from this, this becomes 4 and 3/5 now. Now I have a completely different mixed number on this side. Put a ring around the part that you're subtracting. What is 5/5 minus 4/5? Well, 5 minus 4 is 1, so that leaves me with 1/5. So my new problem is 4 and 3/5 plus the 1/5, and that gives me 4 and 4/5. All right, you can finish out the page.